Okay, so let's look at one example here. Okay, you're given 2 points, point A and point B. Okay, now you observe the bearing A to B, 67, 21, 55, and you observe the distance at 55.289. Then you have to calculate the latitude, then departure. Latitude simply means distance time cos. Departure simply means distance time sine. Okay, but the thing that I want to highlight is you're going to use bearing, not angles anymore. Okay, so you're going to use bearing. So in that case, it's 21,278, and for latitude and departure 51.03. So these are the values that we'll be calculating, and those are the values that we're going to correct rather than the distances themselves. Okay. Anyway, you can do away with this sine and cos function if you use the built-in function in your calculator. Anyway, I'll show you how to do that in a while, but let's look at this example. Okay, you're given 197, 53, 56 from B to A, and distance 75,375. Latitude simply will be the cos, so that'll be the answer. Okay, and departure, the sine, that'll be the answer to departure A to B. Okay, and then you were asked, okay, if the coordinates of A are given as 2367 northing and 6392 easting, calculate the coordinate of B, which simply means you take the coordinate of A, the northing, you add on to the latitude, that will give you the northing of B, and similarly you take the coordinate of A, you add them, the easting of A, add them to the departure, so that will give you the coordinates, the easting of B. Okay, so if you do that, you will get those values written there at the bottom of the screen. Okay, that value there. Okay, let's repeat that calculation. Okay, but now let's look at the function within your calculator. Okay, now let me just play the video. Same calculator. Remember, we used the function minus before, and now we're going to use the other one. Okay, that says RAC. Okay, we're going to convert now. We're going to get polar. Now we are in polar. I'm going to convert that to rectangular. So let's play that video. Okay, so shift minus, so as RAC stands for rectangular, so you key in the distance 75, 375, comma. Okay, so that's the distance, 75, 375, comma. Okay, next you have to put in the angle 197 degree, 53 minutes and 36 seconds, and close the bracket, and you press equal. That gives you the distance 71, 729. Okay, so that's the same. Okay, 71, 729. Then press recall tangent, so that will give you your departure. okay, which is 23.159. Okay, I'll just bring that forward there. So 23.159. So that's now equal to that. Okay, so that's how you use the function in your calculator to calculate those values easily. Okay, you don't have to worry about which quadrant it will fall in, because if you notice, automatically it will give you a minus, because now we are going south and going west. Okay. All right. So next, traverse misclosure. Okay. Now we have taken care of the angular misclosure, and now we're going to be looking at the distance misclosure. But as I mentioned earlier, we won't be looking at the distance themselves, but instead we have to apply the correction to the latitude and departure for all the traverse legs. Okay, assuming we are performing a loop traverse, a closed loop traverse, then if you sum up all the latitudes and sum up all the departures and there's no error, it should be theoretically 0. Okay. For a link traverse, however, okay, assuming there's no error, the sum of latitude should equal to the nodding of the last station minus the nodding of the first station. Okay, and the same applies to departure, whereby you take the difference of easting between the first and the last station. So that's the theoretical value. That's what you should obtain. Okay, that's what you should be comparing your latitude departures that you have calculated against. Okay, let's do an example later, but for now, let's look at what we mean by errors, what we mean by handling the errors. Okay, in practice, because of random errors, when you sum up all the latitude and departure, highly unlikely you will get 0. You will get a number. Let's call them E, N, and EE. It stands for error. So error in nodding, error in latitude, and error in departure. So that gives them a number, a name. Okay. So the values of EN and EE, or these two errors, give rise, because they are distances, linear distances. So the sum of these two distances gives rise to what we call as the linear misclosure. Okay. Linear misclosure, we evaluate. You have to calculate them. Okay, and you have to look at it. There's a standard that we adopted. If it's not up to the standard, you may have to repeat your traverse work. Okay, and then we're going to apply the appropriate correction, provided that we have met the standard. And another important thing to note, that when you write down your linear misclosure, okay, because they are basically indicators to the accuracy of the traverse. Okay, so if your linear misclosure is 1 in 6,000, and someone else doing the same job will get let's say 1 in 8,000, meaning that yours is not as accurate as the other person's work. Okay, so the bigger the number, the better the accuracy is. Okay, anyway, when you write them down, you write them either to the nearest 100 or to the nearest 1,000, like so. Okay, forget about the decimal places. Okay, just nearest 100 or nearest 2,000, as what people normally do anyway. Okay, right. So what's this EN and EE? Okay, so assuming that you have traveled from A, okay, you go to B, C, D, and perhaps you came back to this point here, X, and finally you close your work to A, and because of errors in angle and distance that you observe, so your final value here, the final position A that you observe is not actually A, now it's A prime. Okay, because you're probably short of a few meters, of a few centimeters, and your angle will be off by a few minutes. So that distance there, the EN, the EE, when you sum up the latitude, so that's the linear sort of displacement of point A from its actual position. So this gives rise to a linear measurements from A to A prime, which is basically a Pythagoras. So you calculate that using your error in nodding and error in easting. Okay, so you either normally what we do when we write linear misclosure, we write it in that form. Okay, whereby sigma s is the total distance that you travel for the traverse. Okay, so 1 in sigma s divided by E. And for engineering application, that's the standard that we're looking at, minimum. So if you get anything lower than 4,000, you have to resurvey, re-establish your angles and your distances. If you get more than that, then you are good. Okay, your work is done. So 1 in 4,000. So linear misclosure 1 in 4,000, angular misclosure 2 minutes, plus minus 2 minutes 30 seconds. So those are the two numbers that you have to remember when you are doing your traversing work. Okay, so how do we adjust? How do we apply the correction? So there are so many, there are a few actually methods that you can apply, but I think for our purpose, we could apply a method which is known as the Bowditch method. Okay, so Bowditch method will apply correction to the latitude and departure by taking the ratio, okay, between the actual length measured against total length and multiply them by the error itself. Okay, and the same goes to correction in departure. Okay, total length divided by total traverse length multiplied by the error in departure. Okay, so that's basically what Bowditch is. Quite straightforward, simple corrections, which means that if the length is long, a longer length will get a greater correction, okay, a bigger correction compared to a shorter length. Okay, so the final coordinates of traverse stations are then computed using adjusted corrected latitude. So you have your calculated latitude, you do your Bowditch correction, then you'll end up with what we call the adjusted latitude or the corrected latitude. So you're going to use that. That will be your final answer. That will be your value that you use to calculate your coordinates. Okay, so before you could start calculating coordinates, normally you will need the coordinate of the starting station, okay, either given or you have to get it from any existing records that's available. Okay, and when you're done, okay, in the calculation, when you finished, there's a way, or you can always look back at your calculation. You can check for any arithmetic mistakes or arithmetic error, mathematical error, okay, when you're punching in the numbers. Okay? We'll do an example later, I think in the following slide, and we see how this correction are applied and how the checks can be done. Okay, before we go on to that, let's finally lastly look at this. Okay, apart from calculating your final coordinates, you are also able to calculate areas, okay, from the loop traverse. Okay, so if you consider a traverse with 4 stations here, and having done all the traverse work, you get the coordinates of each station. Okay, so if you just list down in a column like that, northing 1, 2, 3, 4, and you repeat the first one. Similarly here, you write down the easting, you repeat the first one there. Then what you do next, okay, I will probably change color now, I'll take yellow. You do what we call cross multiplication, okay? NY multiply NE plus N2 multiplies and E3 and so on. So that's here. Okay, so change to green now. So that's this one here. Okay, then you do the other way. Okay, or to the other side, the other side, going up or going down, doesn't matter. N2, E1, N3, E2, and so on. So that's that there. So you take the sum between those two, and the difference in the cross multiplication, in the sum of the cross multiplication will be, will give you the twice the area. So to get the area, you divide by 2. Okay, quite straightforward. So it doesn't matter how many points you have, how many sites or how many stations that you have in your traverse, you can easily apply this method, what we call the cross multiplication method, to obtain the area. Okay, there are other methods that you could use to calculate the area by using the latitude departure. I'm going to discuss it here because I think this is a bit simpler compared to the latitude and departure method. Okay, let's do one exercise on calculations, the entire calculations for traverse, okay, and look at how the corrections are done and how do we assess the quality.
انضم معنا الآن واشترك بالقناة ليصلك كل جديد. YSAG، معا نحو مستقبل مشرق.